You know, in psychology, actually in pretty much any field, we are just swimming in data. But let's be real, a giant spreadsheet full of numbers, it doesn't exactly tell a story on its own. So today, we're going to dive into the essential tools that researchers use to turn all that raw info into something that actually makes sense.
Right. And that's the big question, isn't it? I mean, picture it. You've got hundreds of survey responses, maybe thousands of test scores. It's just a sea of numbers. So where do you even start? How do you find the pattern in all that mess? How do you see the big picture? Well, that's exactly what psychological statistics is all about solving.
Okay, so think about it. It's pretty much impossible to study everyone in a big group. Like, you can't just go out and survey every single person in a country, right? It's just not practical. So what researchers do is they pick a smaller representative group, and we call that a sample. And the whole goal is to study this smaller sample to make some really smart, educated guesses about the entire population. This is like the absolute ground floor for how we start to make sense of all this data.
All right, so here's what's on the menu for today. First, we're going to tackle the why. Like, why do we even need stats in the first place? Then we'll get into the fun stuff, the how. We'll look at how to find the center of your data, figure out how spread out it is, and then, and this is the cool part, we'll see how it all comes together to reveal this amazing pattern that shows up pretty much everywhere.
All right, let's jump right in with the basics. Imagine a statistician has this big toolkit, right? When they open it up, they've basically got two main trays of tools, and each one is for a totally different job.
So, in one tray, you've got what's called descriptive statistics. This is all about just describing the data you've got. It's about taking a snapshot and answering the question, so what does our sample actually look like? Then, in the other tray, you've got inferential statistics. This is where you use that sample data to start making educated guesses or inferences about the much larger population. For today, though, we're going to focus on mastering that super important first step, just describing the data we can see. Yeah, because think about it. Before you can make any huge predictions about the world, you've got to understand what's right in front of you. You got to know your own backyard, so to speak. So a researcher's first job, always, is just to get their data organized and summarized. And that's really the whole point. It's all about making things clear and easy to understand. The goal here is just to lay out the key features of your data before you go making any giant claims. It's really about finding that clear signal in all the noise.
And this is what it looks like in the real world. We're talking about taking that boring old spreadsheet full of numbers and turning it into something our brains can actually wrap around. You know, things like charts and graphs. And when you do that, all of a sudden these hidden patterns and trends can just jump right off the page.
So to get this done, we basically break it down and ask three main questions. First up, how often does each number or score show up? We call that frequency. Second, what's the most typical or central value? That's something called central tendency. And finally, the third question is, are all the numbers really close together or are they spread all over the place? And that, my friends, is variability. These three ideas, they're like the foundation for everything we do when describing data. Okay, let's zoom in on that second question. Once you've got all your data, one of the very first things you're going to wonder is, so what's a typical score here? You're hunting for that one single number that can kind of stand in for the center of the whole group. And that is the whole idea behind what we call central tendency. It's this quest to find a single summary number that gives you a quick snapshot of where the data center is. You can think of it as our first best guess at what a typical score really is. But what's kind of cool is that there isn't just one way to find the center. There are actually a few. The three you'll see most often are the mean, the median, and the mode. The mean, that's just the good old-fashioned average you learned about in school. The median is literally the score in the dead center when you line them all up. And the mode, that's just the most popular one, the score that shows up more than any other. So a simple way to think about it is this. The mean is a mathematical calculation. It uses every single number in the set. The median, on the other hand, is all about position. You just line them up and find the middle one. And this little difference, it becomes super important, especially when your data is a little wonky and not perfectly symmetrical. Which, of course, leads us to the big question. Okay, so which one's the best? And the classic statistics answer is, well, it depends. There's no single best one for every situation. The right tool for the job really comes down to what your data actually looks like. And knowing when to use each one is absolutely key. The mean is fantastic when your data is nice and symmetrical, but it has one huge weakness. It gets totally thrown off by extreme scores, what we call outliers. Like if a billionaire walks into a room, the average income suddenly skyrockets, right? That's where the median comes in to save the day. Since it only cares about what's in the middle, that billionaire doesn't affect it at all, which makes it perfect for skewed data. And the mode? That's your go-to when you're not even working with numbers, but with categories. Like, what's the most popular answer on a survey?
Okay, so we've got a handle on finding the center of our data, but that's really only half the picture. Here's a thought. You could have two groups of data with the exact same average, but they could look completely different. We also have to know how spread out all the scores are.
Just imagine it. Are all the scores huddled up tight around the average, making a tall, skinny peak, or are they spread way out, making more of a short, flat hill? That measurement of how spread out things are, that's what we call variability. So long story short, variability just tells you how consistent your data is. If you have low variability, it means all the scores are pretty similar to each other. High variability, well, that means your scores are all over the map.
So why should you care about this? Well, it matters a lot. Variability is critical because it tells you how much you can trust your average. If the spread is small, then the mean is a really good summary of the group. But if the spread is huge, that mean might not be telling you the whole story. It could even be misleading. Plus, it helps us spot those weird outliers, and it's a building block for pretty much all the more advanced stuff in stats.
All right, last but not least, let's talk about one of the most, kind of beautiful ideas in all of statistics. It turns out that when you collect enough data from the real world, you start to see this very familiar, very predictable pattern showing up over and over again. Yeah, it doesn't matter if you're looking at people's height, IQ scores, even tiny errors in measurement. So many things in nature seem to follow this pattern. Most of the scores get clumped together right there in the middle, around the average. And the further you get from that average, the fewer scores you find.
And this beautiful symmetrical pattern has a name. It's the normal distribution, but you probably know it as the bell curve. And because it's so predictable, it's the key that unlocks probability for researchers. It's basically the bridge that lets us go from just describing our little sample of data to making powerful predictions about the entire world.
So there you have it. From taking a mess of raw numbers, to finding its center, to measuring its spread, and finally to seeing that incredible fundamental pattern, these are the first real steps in making data tell a story. So the only question left is, now that you've got the tools, what stories are you going to uncover?